Okay, now let's apply what we just learned about the primary and secondary immune response and how vaccines fit in. Let's apply that to our specific example of measles, which it's just the measles vaccine is such an effective and safe vaccine that we just love using that as an example for many things.
Thank you.
Okay. Somehow. Okay. So, here's the same graph that we saw before, but now we're using measles as the example. So now we have day 0 is our measles infection. We have the start of the innate immune response, and then 2 to 4 weeks later we have our antibody response, our specific adaptive response, and other T cells. And then we have immune suppression here via the cytokine IL-10, a great robust memory response. Then sometime later we get our second measles infection, and we see that because of that great memory response, we have the adaptive immune system come in right away. 1 to 4 days later, we get production of antibodies, and you don't feel sick, you're not contagious. This is what we want after vaccination. So if now we just change it, and now we're going to talk about, remember, same graphs as before. Now on day 0 we have measles virus vaccine vaccination. So this process is going to happen over the period of 2 to 4 weeks. This keeps wanting to switch slides for some reason. 3 to 4 weeks. We've got the memory response, and then remember the great thing is we're going to have, when we get that first natural infection, that's after the vaccination, then we're going to have really quick adaptive immune response, very, very specific. So that's why the measles vaccine is awesome, because it does elicit this long-term, very robust memory response, so that if you do actually get measles virus, your adaptive system is going to swoop in really fast. Now, something that's really important to remember is that measles vaccine is super effective. That means that it does a really great job of not making anyone feel sick from measles. That does not mean that measles virus isn't around us all the time. So my best friend in the lab, Ashley, she works on measles virus, and she actually has to take a lot of precautions in the lab so that her experiments aren't contaminated, because the measles virus is in the environment all around us. And so she has to be careful that her experiments aren't contaminated by the measles that's in the air. So it's really important to remember that just because you don't feel sick and that there aren't many cases anymore of measles epidemics in the US, that does not mean that measles isn't around us all the time. And that's why it's so important to get people vaccinated against measles, because it's still everywhere. It's not eradicated from the earth like smallpox. It's still in the environment. We just say that it's eliminated from the US, except for some outbreaks here and there, because we're no longer feeling sick from it. So that's the difference, remember, difference between elimination and eradication of a disease. Elimination means it's still on the earth, it's still floating around us in the environment. Eradication is when it's been wiped out from the entire planet.